try an example to design a simply supported one-way spanning slab. The slab is subjected to a GK of 1.0 kN per mm square and a QK of 3.0 kN per mm square. The concrete strength is 25. The steel strength is 500. It is assumed that the exposure class is XC1 and the bar size is 10 mm. The question asks us to estimate the slab thickness, design for the main and secondary reinforcement, and check for the shear reinforcement. The clear span between the supports is 4.5 mm. You may pause the video for a while for you to work out the solution. To determine the slab depth, you need to acquire the basic L per D ratio first. Referring to table 7.4n, which is this, a simply supported slab which is lightly stressed by the concrete, it will have a basic L per D ratio of 20. Assuming the limits is 40% higher, the minimum depth for the slab should be equals to the span divided by this 27, which is equals to 167 mm. In this case, we try to use a round number. The depth is equals to 170. It is given that the concrete class is XC1. By referring to table 4.4n, for the recommended strength class 4, class XC1, the cover for durability is 15, plus the deviations of 10 mm, the nominal cover should be equals to 25. Assuming the bar size is 10 mm, so the overall depth of the slab, it will be 170 plus the cover plus half of the reinforcement bar, which is equals to 200 mm. Next, you need to determine the actions acting on the slab. The permanent actions include the self-weight of the slab and also the permanent actions given in the questions. The self-weight of the slab is by multiplying the overall depth with the unit weight of the slab, which is equals to 5 kN per meter square, plus the permanent load of 1 kN per meter square. In total, the permanent actions, it will be 6. And the variable actions given by the question is 3 kN per meter square. Therefore, by multiplying 1.35 and 1.5 and the 1 meter unit width, the design load should be equals to 12.6 kN per meter. From the design load, you will be able to compute the design moment and the design shear loads, which is obtained from simply supported equation WL square per 8. It will give you 31.9 kN meter moment, and for the shear load is WL per square, and you get 28.4 kN. Next, we calculate for the reinforcement bar area. First, you use these equations to compute the K, which is found to be 0.044, and normally it will be less than 0.167. Then you calculate the lever arm by using these equations. It is found that to be equal to 0.96, which is greater than 0.95. For that, 0.95D is used, and your Z is found to be 161 mm. Substitute the relevant value into the equations. You get the area of reinforcement bar of 455 mm square per meter. Therefore, you provide H10 at 150 mm spacing center to center, which give you the AS provided of 523 mm square per meter. The provided area should be greater than the required area. Next, you cross-check back the deflection. Substitute the relevant equations. Then you will know that your rho is actually less than your rho naught. Then the first equation here is used. Since the slab is simply supported, then the K will be equals to 1. Substitute the relevant numbers into the equations. Your L per D limit, it will be 37.9. Your actual L per D is obtained by dividing the span with the depth, which is 26.5. It is less than the L per D limit. Therefore, your deflection should be okay. Next, you check for the shear resistance. To acquire the shear resistance of the concrete, you need the K and also you need the rho 1. Substitute the equations for the K. You will get the K equals to 2.08, which is more than 2. With that, you will choose to use K equals to 2. As for the rho 1, substitute the provided reinforcement with the BD. Then you will get the rho 1 equals to 0.00313. Substitute the rho 1 and also the K into the equations. You will get the shear resistance of the concrete without reinforcement as 81 kN. Check this shear resistance with the minimum shear resistance of the concrete based on this equation. It is found that the minimum shear resistance should be 49.2. Therefore, we know that the shear resistance of the concrete is 81 kN and it is greater than the shear load. Therefore, no shear reinforcement is required for the slab. Next, you determine the minimum bar area. It is obtained by these two equations. First, you need FCTN. You can obtain FCTN from table 3.1 or by using the equation. With that, you found that your AS minimum is either 218 or 221. The bigger value is used. With that, the minimum required area for the transverse reinforcement, it will be 221 mm square per meter. As the transverse reinforcement is not really meant for load resisting in one-way spanning simple supported slab, therefore the transverse reinforcement is provided with the minimum bar area. It is provided with 10 mm diameter bar at 300 mm spacing with the provided area of 262 mm square per meter. The provided area needs to be greater than minimum bar area. With that, the transverse reinforcement bar is considered acceptable. Then you need to proceed to check for the other serviceability requirement, such as the maximum bar area, the maximum bar spacing, the minimum bar spacing, and the anchorage length. Most of these criteria are not to be quite critical for the slab, except the maximum bar spacing for the slab. Since that we limit our spacing to be 300 mm, So all these criteria may not be that critical. Depending on the questions, you sometimes are asked to find the respective serviceability requirement. This diagram shows the detailings of the slab. You may choose to curtail the reinforcement bar, or you may choose not to curtail the reinforcement bar. Since the provided reinforcement bar is relatively less, and the common applications in the construction industry normally do not curtail the reinforcement bar when the amount of reinforcement bar is less, we will stick with this detailing. Should you choose to curtail the reinforcement bar, the main reinforcement bar at the midspan should be H10 150, and the main reinforcement bar at both ends you can reduce by 50%, so the spacing can be doubled to Y10 300. Remember to indicate the positions where the bars are curtailed.